Hello, Tarmo. Can you hear me? Okay, let's get started. So we are starting with ChainAware and Smart Credit AMA, or in the Twitter space. And usually we are doing our AMAs via the Telegram, but now we discovered the Twitter space, and we actually like it because it's so cool to discuss, and we will be discussing about very, very many different topics. And main focus here is on AI and the Web3 convergence. So how AI and Web3 will converge together. Okay, but let me introduce us first. So, Tarmo, would you like to introduce you first, and then I will continue?
Yes, I'm Tarmo. I'm co-founder of ChainAware and Smart Credit. My background, I was chief architect of the largest Swiss banking platform. If you guys have questions about banking, ask me. I know everything. I have background also in Credit Suisse, 11 years. I did do my PhD in Max Planck Institute in Germany by one of the Nobel Prize winners. I am very deeply in finance area and in crypto over 10 years, 12 years. Okay, Martin, back to you.
Okay, I'm the other co-founder of ChainAware and Smart Credit. So I spent 10 years as well at Credit Suisse. So okay, Credit Suisse was taken over by UBS, but we like Credit Suisse. So it was a very good company. We learned very, very much there. So okay, Tarmo and myself, we have pretty many degrees. So I think I have 4 master degrees. Tarmo has as well 4 master degrees and a PhD. But sometimes I'm getting confused now. I don't remember. Is it maybe more, or was it the 4? So, but it doesn't matter. So, but I want to tell you why I'm referring to these numbers is because we are very multidimensional. We know about very many different topics. And most important that we try to do now in today's conversation is we try to connect the dots between different topics, not just to go deep into one dimension, but to speak over the different dimensions. So, okay, so this is for the intro about us. So, but Tarmo, let's start first with the ChainAware. Could you give a little overview what the ChainAware is doing, the AI functionalities that are in the ChainAware in the production, and how they can be used? And then let's start the conversation.
ChainAware has revolutionary technology, and you guys all know blockchain and Byzantine general's problems that you cannot know who you can trust. And in blockchains, this problem is solved by mining algorithms or proof of stake algorithms or delegated proof of stake algorithms. And if you have more than half or more than 2/3 behaving badly depending on algorithm, this mechanism can fail. What we have done is we can say exactly in ChainAware which Byzantine general is behaving badly. And what blockchain has solved over proof of work of proof of stake consensus algorithms, we have solved it by artificial intelligence. Using artificial intelligence, we can say who are bad actors. And it means that we know which Byzantine generals cannot be trusted and which Byzantine generals can be trusted. And if you take now blockchain and you add our AI technology to the blockchain, it simplifies so much.
Okay, so if you are looking now the AI, let me jump in, Tarmo. So if you're looking at the AI, people are speaking so much about AI and the blockchain, AI and the Web3. But the question is now, what are the real use cases? No, we started with the ChainAware algorithms before this ChatGPT and all of this emerged. Okay, it developed out of a smart credit. In smart credit, we did a credit scoring algorithm, and for credit scoring, one part of a credit scoring was a fraud detection algorithm, which on the end is a trust algorithm that Tarmo just referred to. So practically we worked before this ChatGPT failed on the trust algorithm. So, and now if you're looking on the AI and the blockchain, You see, if you're looking at the CoinGecko, you see that there's tons of documents, projects which are doing just like a AI generation, generative AI. They're generating something. But is this now a blockchain usage? Do you really need a blockchain for this? So our viewpoint is fully different. We are not doing any wrappers around the ChatGPT. And let me make a little footnote here. If you're creating a wrappers around the ChatGPT, like very many projects are doing, if you look at the CoinGecko AI list, we are there in the CoinGecko AI list there, but pretty bottom because we have real AI. So, but you don't need a chat for the ChatGPT. You don't need a blockchain. No, you don't need a blockchain project. So let's get back to now to the AI. What are the AI use cases in the blockchain? So what can be done? So one thing that we are speaking is a fraud detection and a trust detection. That was what Tarmo was referring to. That's the famous story that we have a blockchain. There is an algorithm, and this technical algorithm solves the Byzantine general problem, which is beautiful. But it doesn't say anything about the actors now who are acting on this infrastructure. So you can have 90% bad actors, you can have 50% bad actors, you can have 10% bad actors. We're coming to this problem. Tarmo will add a little bit more on this. No, and this is one use case of trust and fraud, and we are doing this in a ChainAware. And we are coming back to this use case. Just a sec, Tarmo will come back on this use case. But just to the listener, the second use case, okay, it's a crypto credit score. Okay, that's how the ChainAware started with a crypto credit score. Practically, we use the blockchain history to predict the credit scoring. But because how the borrowing lending has been built in a DeFi sector, there's not so high need for the credit scoring. However, it will change, so it's just a question of the time. So till the Web3 sector is then developing further and further. The third thing that we have is as well like you cannot only calculate the fraud, you can calculate even more things like intentions of the users. And intentions now for the people who are coming for the marketing, this is the key, the intentions to do the marketing. If you're looking at Google is doing marketing based on the intentions. And this is our third product. It's a third use case. Now, how to predict the user behavior. Okay, we are coming to these use cases, and there are some more use cases. But now let's get back to this first use case. It's the fraud and trust use case. And Tarmo, this Byzantine general problem. Could you just elaborate a little bit more on this? Just one more time for the listeners. Oh, Tarmo just requested again permission to speak. Tarmo, can you speak?
It is key for all blockchain. And what happens is in blockchain, okay, we can speak about other use cases, Martin, later, about credit score and intentions and segmentation. We can speak later. But what happens in blockchain is that blockchain is an anonymous system. And in some blockchains, transaction costs are so small that you can just neglect them. And now if you take another discipline, social psychology. Social psychology says if you have an anonymous system and you have full anonymity, like we have in blockchain, actors start behave badly. And this is what we see in blockchain. When you have anonymity, you need another mechanism to balance these bad behaviors. And when you don't do it, then bad behaviors will just increase over time. And in real world, in social psychology, it is like these bad behaviors just will culminate till it just it's too much, and it's like all over. And what we need is something that balances this bad behavior. And technology that we have is that we can say who is bad actor and who is a good actor. It's the trust score we offer in ChainAware. And you know who you can trust and who you cannot trust. And it means people are still anonymous, actors are still anonymous, but you can say, I can trust this guy, or I can trust another guy. And when you use blockchains, this should be your first question. Who can I trust in this anonymous environment where just by human psychology, people or actors start behaving not only in good ways? Martin, back to you.
Exactly, and then we are getting this fraud. That's a fraud detection. So an AI is a perfect thing to detect a fraud. Okay, Tarmo and me, we have been in AI pretty long time. So, but let me just add some words like how is then AI applied? Okay, it's not a generative AI, it's a predictive AI. Practically, you create your own models. You create your own models and you train these models. You have model algorithms, then you have a training algorithms, you have training data, and you iterate. I think for us, till we got our model running, the fraud detection model running, we have it now running on 98% prediction power, meaning that if you give an address, we predict with 98%. It's a back-tested, is the address a fraud address or not address, just based only by the blockchain history, nothing else, only by the blockchain history. So, and this is for us the real AI. And fraud detection being an example, you have to create a model. Practically, you create your AI model, you train the AI model, you iterate, and this will take ages. It will take you 12 months, it will take you 18 months. So at first we got in this fraud detection as well, like I think 60%, and so then we made a qualitative jump on 70%, but then we were stuck, and so then slowly we had this iterative approaches. You move further. Okay, and maybe if I'm going too much in the detail, we even got the model running on 99% on the predictability. But what happened at 99%? This is what because we want that our model is a real time. That is a real time model. Because the scams are happening real time. You cannot use the traditional fraud detection systems, like to predict the scams. You need because what's the issue with these traditional fraud detection systems? Okay, either they are AML algo based. We can speak later about this AML algo. They are just some backend processing, so it takes hours, sometimes days, and even longer than to get the data. So that means that AI and fraud detection is like life. So you get the blockchain data, you get the fresh blockchain data, and you have to answer very, very fast. Now, in our case, we are 99%, but then we realized some big addresses, like a Vitalik, that took like a 22, 3 seconds to calculate, and then we said, no, that's too much.
Yes, it has to be faster. Yeah, it has to be real time.
Real time. And then we downscaled the algorithm. And we said the speed, just the value that what we are getting just by adding the speed, so that you get the very speedy answer is much higher than this 98 to 99%. And we downgraded the algorithm on the 98%. And we are now pretty happy with the 98% prediction power.
It is very strong.
Yeah,
very
please,
strong. And what it demonstrates is how high prediction power you can get from data in blockchain. And when you have data in blockchain, it is real data. For every transaction, you have to pay. If you are in Ethereum network, or if you are in networks where you have higher transaction cost. And you just don't do transactions just for fun. No, you want to do something with real transactions. And this data is very, very high quality data. And with this data, you can calculate not only your fraud score or trust score, how trustable you are, you can calculate a lot more. And fraud score, what we have, 98% probability, we can say, who are fraudsters. It is just an example what you can do with data, what is in blockchain. Blockchain has very high quality data. Martin, please.
Yes, let's jump here. This is a proof of work. Like how did the blockchain emerge? One of the key discoveries to create the blockchain was this proof of work concept. Okay, for the Bitcoin, now we know the Ethereum a little bit diverged from the proof of work, but let's stay on the proof of work. And the proof of work emerged, this algorithm emerged during the email problems. Like there were so many email scammers, and the question is like, how do you get rid of all these email scammers? So if every email sender has to do a certain work, then you can avoid the scamming, because the scamming is not anymore profitable. So, and that's the proof of work algorithm. So that means if you are looking now in the fraud detection based on the Ethereum network, on the other networks, every transaction is a proof of work, because for every transaction you have to spend some time. You have to submit transactions, you have to check, you have to prepare the data, you have to think what you're doing, and you have a cash cost. You have to pay the cash, meaning it will cost you real money. And if things will cost you real money, then you're probably doing the real things. Now, let's make here a parallel to like a Facebook. Like I can create a Facebook account. I can declare myself to the king of UK or Britain or so, and I can pretend that I'm so, and nothing stops me to doing this. Okay, I cannot impersonate whatever King Charles or who is. So I cannot impersonate it, but I can pretend to be anything. No, but in a blockchain, we have real transactions. And these real transactions, they're telling much more about the real users than all these pseudo transactions, pseudo data, like what the users are posting on the Twitter, on the Facebook, and so on, or even like emails or the social conversations. So the question is always is proof of work. Proof of work. Is the cost involved? Yeah, Tarmo.
Yes, and when you speak about Facebook, you guys know that Facebook acquired WhatsApp, and acquisition price of WhatsApp company was $19 billion, and everybody said, "Oh, it is too much. It is too much." But nobody understood except Zuck that he's got real phone histories, and he was ready to pay for real phone histories this time based on numbers of WhatsApp users. It was like $70 per user phone history log. And this is just an example if you have high quality real data. And what we have in blockchain is the same. We have in proof of work blockchains, we have very high quality data. And to calculate fraud prediction, it is just one example. And 98%, it just illustrates how high is the data quality that we have in blockchain. And what it means, Martin, is that it is just beginning, and we can calculate not little more, we can calculate a lot more based on this high quality data in blockchains. It's the same as Zucky paid 90 billion for WhatsApp. He understood the value of WhatsApp, and it was the call logs, the data. And what we have in blockchain is that all this data, which is actually worth billions, is publicly available. All you just need is take this data, start calculating, and train your algorithms. Okay, Martin.
Okay, and let me. We are coming back to this, and let me just make a small overview about this fraud detection systems. So, because there's a Chainalysis, there's a CoinFirm, there are some other companies now. Like and if you're looking at traditional finance, or regular banking, there are two fraud detection systems, and this is mandated by the regulators. Actually, it's mandated by the regulators as well for the CeFi companies and more or less for the DeFi companies. If not yet, it's coming now. These two components are first, it's an AML monitoring via the AML algorithm. Now, if you have worked a little bit in a bank, like Tarmo and myself, you spent 10 years at Credit Suisse, then you know this AML algorithm. And the second is a transaction monitoring. Now, AML algorithm tracks the illicit funds, the bad funds. And that's what most of the fraud detection platforms are today doing. They are just tracking the bad funds like a ChainAware, CoinFirm, TRM Labs, and so on and so on. So it's an AML algorithm as it works in a traditional finance. So it's more or less taken one by one, it's over. And then it's run. And because the clients are the central finance companies, meaning not Web3 companies, you don't need a real-time process. So that's the first part. Now the second part, in a traditional finance, it's regulated. It's mandated by the regulator. You need a transaction monitoring, and transaction monitoring is AI based. It's a pattern matching system. Because the AML algos, you can fake them, you can bypass, you can mix the monies. Okay, we're not going into the details here. I don't bypass the AML algos. Okay, but there are certain patterns, and humans, okay, people like we have certain interaction patterns, and transaction monitor, which is like we can say 100% is in traditional finance is AI based, is recognizing these patterns. So, and that's exactly what we are doing. So the fraud detection in a blockchain, there are two parts. The one part is kind of overdeveloped. It's an AML algo-based approach, and the second part is a very then underdeveloped. That's the transaction monitoring part. Okay, just wanted to add it about the fraud detection in case like someone will say like, hey, this Chainalysis or some other guys they are doing the fraud detection.
Chainalysis is very good for documenting frauds which happened in the past. So you can say, okay, 3 days ago following fraud happened, but then it's too late. Your funds are already transferred, and this is the situation what we have currently on the market. Market is AML market goes like into a technology which shows you, oh yes, it happened in the past, but can you change something? Did you protect your customers? Did you help your customers identify wrong partners? No, you didn't. And this is what we have currently in blockchain industry, the technologies which at the end don't help customers are made popular. And technologies which would help customers, like to be sure that my partner I transact to or another actor is trustable. These technologies are more like not so much known, and this is why this is a situation. Martin, what's your viewpoint?
Oh, okay, and I just got an idea which I didn't got. I connected some dots now just in Twitter space. You know, Tarmo, why the Chainalysis and all of these are so much pushing the AM algo? Because this AM algorithm, AML, anti-money laundering algorithm, it came from traditional finance. And in a traditional finance, you can reverse the transactions. If a transaction is proven wrong, the bank has obligation. It's a part of a banking license. You will not have banking license if you cannot reverse transactions. Yes. It's simple. So, and therefore, so you do it. It doesn't need to be real time. There's no requirement to be a real time. Like a AML algorithm saying, oh, there's something fishy. Then the compliance guys are jumping on this. They will analyze it. Maybe they go on the weekend. Maybe they go on a vacation. And someone later, then they will realize, oh yes, this was a fraud transaction. It will be reverted.
Yes.
So, but. And so this guy is like that's unbelievable. Like all these huge investments, monies went into this AML algo, meaning where is the assumption is that you can reverse transactions, which you cannot reverse in a blockchain. And all these huge investments, monies went into the Chainalysis and Chainalysis coin firm and all the others, and as well the forensic databases that they are building and rules-based databases. But these are backwards-looking systems. These are backwards-looking systems for the compliance people that, oh, there was some phishing. Yeah, let's mark this address as a phishing. Now we know it's a bad address. Or there was something else. Let's mark this address. Or there was something else. Let's mark this address. First, this address marking himself, it takes ages. We can make an example like someone created a rug pull on the ChainAware and okay, we found it out very fast. So we reported the address and just from interest, we measured the time, like how much it takes, like from the moment when you report an address till the address is then entered. Yeah, it is a rug pull address. It is a bad address. Let's say it in this way, from some systems, we even didn't got a response that the address has been included. So it doesn't matter. So back to the point being, these are traditional fraud detection systems, which are this AML algorithm based. Okay, let me explain the AML algorithm. It's like, let's say some funds, you have some addresses which are 100% tornado addresses. Okay, these are bad addresses now. And then this flow, the money starts to flow through the other addresses. Now the money is flowing. And now in every next address, in every next wallet, you look, what's the percentage? now of the good money, what's the percentage of the bad money? So practically you take a wine and you mix it with water and with some other things. And then you look like how much wine you have on the end and on the target addresses. And that gives you this AML score. Now, this is perfect for doing the AML, which is regulatory mandated. And we know that in a traditional finance, you can reverse the
But you
transactions.
can't reverse transactions, Martin. Your transactions, if money is already done.
Yeah, so and in traditional finance, you just reverse transactions. It's no problem. No problem. Bank he is obliged to do it. And which is very interesting. And then this approach got copied one-to-one into the central finance. Okay, very much because of the regulators, because regulators requested this. You know, it was a story. Bitcoin is used for the money laundering. Well, Bitcoin is not so much used for the money laundering. There's another currency. We will not go into this topic, but one other very famous currency is used like 100, 1,000, or 1 million times more for the money laundering. But we will not mention how this currency is called. But everyone knows it anyhow, so we don't need to mention it. So, but that's how it emerged. That the fraud detection systems, they became very static, very rules-based. They were like some compliance tools, and maybe you have seen these nice, beautiful charts that doing these flow diagrams, how the bad money is flowing to the good addresses, and then the good addresses get as well like this bad codes on them.
Yeah.
So, and this is
what we explain. We don't have to go into details. It just shows that the approach that we have currently in the industry, it is actually not meeting customer needs. And what customer needs, or what users in blockchain need, they need option to revert transactions which are made with fraudsters, or to avoid these transactions. And in blockchain, we can't revert transactions. So we have to avoid bad transactions and avoid interacting with bad partners. And
exactly, we need to predict like these addresses may be bad. I don't know the guy behind the address. Do I really want to transact with the guy or not? So we need a prediction. So because regulatory AML algorithms are connected with the reversibility of transactions not given. So we need to predict it. And in a Web3, I'm interacting with other guys. Okay, not in a central finance. In a central finance, I'm sending my transfers from Binance to whatever Kraken, and from Kraken to Binance back. And both of them they can block the transactions. They can block me receiving my funds. So or anyone else on whatever the legal requirements that they have. No, but if you're on the Web3, we need immediate. There's no other party between who is saying, oh yeah, you need to reverse these transactions. You cannot do it. And this means that you cannot use this AML and rules-based and forensic rules-based data and rules-based algorithms. You need a prediction algorithms. So, and we are speaking about this, and for us it's so self-explanatory. But the Web3 has to go into the predictive power. Because what's the beauty now in this? Let's trace a little bit back. So we spoke about the WhatsApp, and we spoke a little bit about the Facebook, that Facebook took over the WhatsApp. It was ages ago, like 10 years ago when it was, I don't remember. But it's a proof of work now. Your address is your business card. You have done some proof of work for your address. Sure. And you have done this maybe not over like the last week, you have done this maybe over the last month, 6 months, 5 years, like a long time. And this is your business card. Now, do you really want to destroy your business card? No, probably not. Sure. And and people are saying it's bad that blockchains are like what's called anonymous or pseudonymous. But the transaction history is there. This transaction history of any address is the best business card of any person. So, okay, we are speaking here of the fraud. A little bit looking at how the other fraud algorithms are working, that are used, that they are not fitting for the Web3 economy. But your address is your business card, and if you're a scammer, you can do one scam. But maybe it will need for you like 6 months to build up this good reputation. But we really want to destroy it. So Okay, that's like the fraud detection. So should we jump on the other possibilities that
Yes,
can be?
maybe
Tarmo,
Martin,
please.
let's have a look on intention. It is maybe also best, and then after that, credit score.
Like, okay, we spoke now a little bit, maybe too long about fraud detection. Okay, now, but you see, fraud is actually nothing else as a prediction that this user probably will commit fraud in the future. So that is, the user has intention to connect a fraud, and we are saying that the probability that he will connect a fraud in the future, we show this predictive fraud thing. But now, exactly in the same way as you can calculate the fraud, you can calculate as well other properties. Fraud is just the one behavior. There's someone whom I don't want to trust. But I can calculate now the properties. Is this guy maybe a borrower? Is he an intention to borrow? Is this guy a trader? Is this guy an investor? So is this guy like some NFT guy? Of course, I can look on the transaction histories and so on. But it's not about just looking at the transaction histories and saying this guy interacted, let's say, with some NFT platform. It's about predicting what he will do as a next. But technically speaking, so we have intentions, and fraud is fraud being one of the intentions. So there are other intentions. And if you're using a ChainAware, then you see for every address, if you just type in vitalik.eth on the ChainAware, then you see this predicted fraud for the Vitalik. Okay, he has a pretty good trust rating Vitalik.eth. But you see as well his intentions. So we are calculating what are his probably next step on the blockchain. Now, so it's not only that your address is your business card, meaning your business card that you give to other people and saying, hello, I am Martin, here's my business card. And everyone can look on this. So from this address, we can calculate what this gentleman or lady will do as a next. What will be his next actions?
Yes.
Now,
what is she or he interested for? What is or she looking for, and what will he or she do in future? And back in times when I was chief architect of largest Swiss banking platform, we used transactions history or real payments history to predict such things. And what we had, we could predict a customer's behavior like 12 years into future. And say in 2 years he's going to buy a car, in 7 years he will do mortgage, etc., etc. Just based on transaction history, we had capability to predict fully when customer was going to do something in future. And what we have now, what Martin explained, is the same for blockchain. All we need is just transaction history for an address or for an actor. And based on this address history, we can say in future following happens. In 2 years, following will happen. In 7 months, following will happen. And if you take now amount of data when I was chief architect, we trained it with around 100 million transactions, and we had very good predictive power. And now when we take blockchain, in blockchain in Ethereum, Martin, I don't know, we have billions of transactions. We have more, and we have very high quality data. And it means intentions, what we calculate from data in blockchain, they are very accurate. And it is like the value of blockchain data, it's all public. It is incredible. It's unbelievable. If you know an address, you can predict what is he going to do in future and when. When is he going to do something in future? It's unbelievable. Okay, Martin, back to you.
Yeah, and we want to speak about the AI and the Web3 convergence, and this is just one of the examples, the intentions. Because the intentions of a persons, they are very much mapped to the personality. So by analyzing the blockchain address of a certain person, we know his personality. We know what is next. And they're saying fraud is only one characteristic of a personality. Is this guy like probably doing a fraud in the future or not? But we have all these other things. And we are not just predicting on address, what the address will do us next. We are predicting what the person behind the address, who owns this address, will do us next.
What is she or he going to do in future, and when is he or she going to do it? So it's like we predict this is how you will live your life based on your past transactions. And predictive power of these algorithms, it is incredible. And you saw it by fraud, 98% prediction power, and by other intention algorithms, it's quite similar. And it just shows what can be done with data, what we have in blockchain. And when you have now these intentions, Martin, we can explain marketing funnel or how marketing is working.
Exactly. Exactly. Let's speak a little bit about the Google, about Google AdWords. Like how is Google working? Google's Web2 is working very simple. He has your search history. Okay, your Google account, they see your search history. And they see as well your browsing history. Okay, usually this browsing history is then transferred to the Google, and you say this, I accept the captchas. With the captchas, there's always the transaction history then submitted back to the Google. Okay, so practically Google has your full browsing history, and Google has your full search history. Based on these things, Google calculates your intentions. So, but based on the intentions is the marketing system work. If you know the intentions of a Web2 person, you know which ads do you want to place on this person. Now the issue with the Google is like if you're looking at a Google marketing system like AdWords and so try to access the data. Actually you cannot access the data. Now, Google has thousands of algorithms per each of us, per every individual. Okay, they're officially not committing it, but they have a lot of data. But they make a public available a very small amount of data. And this is a highly clustered, let's say the guy is technical, the guy lives in San Francisco, or he's from California, and something of very high granularity level. Now, what you don't have is a one-to-one. Now, Google has this data, but they don't expose this data. And that's the reality. That's the reality in a Web2 based on your search history, based on your browsing history. And this tells a lot of you. But again, there's no proof of work included. We spoke before, like pretty long about the proof of work. You have to spend real money, but just the browsing is not real money. Okay, maybe your working time or so. Well, search history is not real time. It just shows that you're something interested. But if you have proof of work, it tells you, meaning real transactions where you pay money, it tells much more. But the issue here is you don't have any access on the one-to-one. Now let's take a blockchain. Let's make now a jump on the blockchain. And you probably know already what I want to say. It's very simple. If you have intentions, you can make one-to-one marketing on this wallet owner. You know his intentions. You know what he will do is next. You know what he will not do. So you know both things. He will do this and this and this, and he will not do that and that and that. Now, and this is you have one-to-one persona. Now, okay, like say we have pretty many different educations, and we have pretty strong marketing educations. Marketing, you always create a persona. Okay, you say my persona is like this or this or this or this. You try to create like a physical persona and just your targeting. Now, in this case, we have one-to-one marketing because you know that's the address, that's the persona behind the address, that's the real person, not anymore persona, which is artificially created, the real person, and you know his intentions. And if you know his,
let's try to give maybe some numbers. And let's take now Web3 marketing. And first you buy clicks, and then you have somebody sees your ad, and maybe he or she clicks on the ad, and then he or she lands on your homepage. And now what will happen as next? And in Web3, then we like, some user is on our application. Yeah, what will we show him? And now, if you show the user wrong things, he will not transact with your system. And this last mile, how to get user to do transactions, it means you have to know his intentions.
You said it. Because the marketing on a Web3 is extremely expensive, and there are two parts. The first part is get users to the website. Okay, you pay some shillers, oh sorry, these are called influencers. You pay some influencers tons of money, you buy some media tons of money and so on. So you get users to the website. Now, he's on your website. How do you address him? How do you give him the right messages? Do you really want to show the same website, the same messages to everyone because you created some marketing persona, like how they're teaching you in the marketing courses, like they're still teaching this to you? They are not yet on the Web3, or do you want to do him one-to-one marketing? So you pay tons of money to the influencers, you get these users to your website, and then you give them all of them the same message. Really? Is this what is a Web3 marketing? But yes, that's how it is. This is a Web3 marketing at the moment. Get the people on the website, and let's hope that some of them will now transact, that some of them will like now my website and all these cool designs, cool user flows. No, it's not about cool design, cool user flows. It's about which messages you place for him. But the messages are person dependent, one-to-one person dependent. It's not anymore some abstract persona that you create in a marketing lectures, the marketing courses. It's a real person, one-to-one. If you know his intentions, you know him, what messages to give to him.
And Martin, what we are talking about is actually the biggest problem that we have currently in Web3, that marketing is so expensive that Web3 companies cannot bear it cost. And when they do it in this traditional way, then you can say one user of approximately 1,000 users who come to your website will transact. And it means you will lose 999 users. And when you know now intentions of users, then you will lose maybe also some users, but you can show them messages that correspond to their intentions, but even users often don't know. And what it means is that conversion rate goes from some 0.1% up to 10 to 30%.
Yes. Let's look at these Web3 projects. Okay, the question is, of course, like how many Web3 projects are there now? Okay, you can look at how many are listed on CoinGecko, I think 10,000. You can look at the DeFi Llama, let's say there are 3,400, 3,500. But in the reality, there are much more Web3 projects. And now, what the Web3 projects usually do, they create a token. Okay, the token is then sold, and they finance via the token. But this is non-sustainable. This is non-sustainable because the token has like a certain age, but you have to generate the revenues now. You have to start to generate the revenues. You have to get the transacting users. Okay, of course, we know there are like very many projects which just create a token and have no intention to create a real working product. Okay, but let's say there's a percentage of projects who want to create a real working products, and they have not this challenge. So you have to start to create revenues, like transacting. You have to need the transactions in the platforms. So, but the issue is here, there's a huge marketing cost because the Web3. If you look on the user basis, okay, in the Ethereum, but we have now 250 million addresses. I don't know, 50 million users maybe. On the other layers too. So we get maybe 100 million Web3 users in total, and but not all of them have the asset basis. Not all of them have your intentions that you need on your platform. So, and you as a Web3 platform, and now you're faced with the challenge. How do you get now these users who are interested in your product on your site? Okay, problem one. The problem two, if they're on your site, how do you convert them? And this, let's focus on this conversion problem, because the first problem, people are still addressing with the influencers via the media, via the other whatever clever guerrilla approaches. Now the users on your website, what do you do? How do you target them? Okay, we just mentioned this before. Do you really want to give to this users who are coming to the website, to everyone the same message, like this is the message, that's the universal message, and all you have to target. Okay, that's just a hypothetical question. We all know the answer. You need one-to-one target.
Martin, even Gartner says that in 2025, 70% of applications will adapt it to the users. It's even Gartner. And now it looks like Gartner is ahead of Web3 industry. So Web3 industry can catch up what Gartner is saying. Sorry, I had just to mention it.
Mm-hmm. Because in a Web 2, like this, a transition is going to this, but in a Web 2, because the data, the intention data is calculated by the Google, and this, Google is not giving this data to the others to use. It's just a very high granular data that can be received from the Google. Then for the marketing purposes, this means that Google keeps its monopoly position in the marketing, just not by sharing the data to others. But no one is speaking about this, but that's a discussion of some other Twitter
Martin,
space.
you see how in Web2 platforms, intentions of users are known based on Google device IDs, and there is transformation over to these adaptive applications and applications which increase conversion of users to 10-30%. That 30% of users transact with your web platform. And it's very interesting to have a look on it and to see that innovative platform Web3 is like behind the Web2. The Web2 takes over this approach that it goes over to one-to-one marketing. It goes over to increasing conversion rate to 30%. And in Web3, we are like behind Web2. It was always all these years I have told to people, look, in Web3 we are in front of Web2, and now it looks like Web2 is in front of Web3. So something has changed, and what we see is that innovation in Web2 takes more focus on conversion of users over to transacting users than in what we have in Web3. Okay, Martin, back to you.
And maybe there is this simple reason, because the businesses on the Web 2, they have to generate revenues, and the only way to generate the revenues is via the one-to-one targeting on your end users. You have to know who your end user is, which messages to give to your end user. So you need to know it. You have to get to the one-to-one targeting. Now, but because so many Web3 projects, they are surviving on the tokens, and so they are not so revenue dependent yet. But to survive a really long time, the Web3 projects, they will need revenues.
Not only to survive, but to flourish and to get crypto adoption. It's always like all people in crypto are complaining, oh, crypto is not growing, crypto is not growing. Why is it not growing? It's not growing because first we have so many fraudsters in crypto. And second, it's not growing because Web2 takes over a leading role, and in Web3 we even don't use approaches what Web2 uses, and these are the reasons. So we have lost kind of innovation power in Web3, and it
Very good point, Tarmo. If I jump again, because on the beginning of today's Twitter space, we're speaking of this fraud detection systems on the crypto space. That most of the fraud detection systems, I'm just repeating what we said before, are using the so-called AML algorithm, which is built on the assumption that you can reverse the transactions. So that the compliance guy sees something on Friday, he's tired, and then he just checks it on Monday afternoon when he's back in office. Okay, not every compliance guy is so lazy. Sorry if I'm buying it. Now, this is one thing. Now, the second thing is the marketing. Now, Web3 marketing is pure mass marketing. So you are putting the same messages on everyone. But where is the one-to-one personalization? Where is the same one-to-one personalization what the Web2 is doing? It's missing.
Yes, and then we complain that Web3 is not growing. So we do wrong things, and then we complain, oh, it don't grow so good as we want. And
yeah, and the fraud problem is, let's think now. Oh, we try to keep the Twitter space on 60 minutes, not to overstretch the listeners. 10 minutes remaining. Let's think now on the journey of a new users. Okay, let's say he's a Binance user. He's a Binance user, BNB, because a BNB has a cheaper transaction cost. Okay, proof of work topic again. Now he has a cheaper transaction cost. Now he's going in some pool and creating some tokens. Okay, now fraud detection, rug pull detection. Okay, like there are no tools for the end users to predict, is this a rug pull or not? Now, is this an issue? Actually, it is now. I don't want to give you now the exact numbers, but we can make everyone the experiment. Like, just take a PancakeSwap address in the Binance chain, go on this address and look then on the pools created. These are below the internal transactions. Now, in every hole, you have like a 20 to 30 pools created. Yes, in every hole, 20 to 30. Hundreds of thousands of pools created on Binance. Now take one pool, go into the pool, and you will recognize a very, very common pattern. The pool, like lifetime, is like a one hole. So it's filled up, and then certainly there's a rug pull. Also, just someone dumps all the tokens, and the pool is dead. There's nothing after that. It's gone. It's a repeating pattern, again. Now, why I'm speaking so detail about this Binance pools, or what is happening on the Binance or on the Pancake, there are no tools available. And now all the fraudsters, all the fraudsters, for them it's like it's called, okay, I know the German word now. Okay, how do you say in English? Okay, it's open season for shooting, let's say, on the new guys who are joining the crypto sector, because the crypto sector will not have, the new joiners don't have any tools. There's no tools for them to protect themselves from these shillers and shillers. So yes, they are shillers. So, and then they're shielded on some platform. They're coming to rug pull. They're going to next token rug pull, next token rug pull. So, and this is the hard reality. Okay, and if you're looking like some statistics, like 90% of our pools, 90%, actually a little bit more, I'm not going to detailed statistics, we are just still running them. But 90% of the pools, they have this very short lifetime, and they are rug pulled. But how can people predict it? There are now some tools which are analyzing the smart contracts of the token. But if you are a rug puller, you will do a clean contract. You are not creating a contract with a bad constructs with some taxes and unlimited tokens, or transferring the ownerships and yada yada. There's a lot of these ways how you can scam during the contract lifetime. You just do a rug pull at the end. How you discover it? Now, very easily. We are the predictive AI. We are the predictive AI of the guys who are creating the addresses. Now, if the guy who created the addresses has only 2 transactions, meaning incoming and pool creation, you look on this incoming transaction, who sent it, and you continue this as long as you find the guy who had more, the address who had more funds. You check on him. If he is trustable, the pool is trustable. If he's not trustable, the pool is not trustable. But let me give you a hint. If there are multiple steps from the guy who has real funds till the pool, so multiple steps, it's already a first indication the pool is not trustable. So, but all these new people, okay, and Tarmo was speaking about people joining the Web3 sector. All these new people who come in the Web3 sector, like probably they get some Telegram groups, they get some Twitter groups, some Discord groups, and something is shield. This is some very cool token. Go and use this token, and rug pull. They don't have any tools available.
Yes.
And later people are whining why there's no Web3 adoption.
Yeah,
Tarmo,
and after you have done like a user, you have a victim of 4 or 5 rug pulls, then you say, oh no, I don't do it anymore. It's enough. And this is what happens in crypto. We have a technology in place which would protect newcomers from rug pulls. We have technology in place which would protect newcomers from all fraudsters. And we have a technology in place which could help newcomers to start using Web3 with real transacting behavior. and it's all in place, and this is what we offer for crypto community, for all Web3 community, and with our intention that we can get Web3 again ahead of Web2. Okay, Martin, back to you.
Like I said, ahead of the curve, because Web3 is now behind the curve.
Yes.
If you're looking at the fraud detection system, it's unbelievable that Chainalysis, CoinFirm, TRM Labs, all these big boys that received all these investments and which are built on the wrong assumption of that they're using AML algorithms to predict the fraud.
Mm-hmm.
This is only for the compliance guys who are then reversing the transactions or blocking the transactions so that the client cannot receive the funds. It doesn't work on the blockchain this way. It just doesn't work. But so in our eyes, well, the innovation was not directed there where it is, because the innovation is there where you use the blockchain data to predict what is happening
Yes,
next.
and this is AI.
But
this is the topic of our conversation, Martin. How actually
this is the topic of AI.
Yeah.
And here is the issue now. If you want to do it, you have to build the model. You have to train the model. And training the model requires special skills. It's not that you're just, let's speak it openly. If you look on the DeFi projects, if you take top lending projects, like 25 top lending projects on the Ethereum, only 5 of them have their own source code. Now, Smart Credit being, of course, one of them, Compound being another, there is Notional on the third one, and there are 2 more. Okay. Now, but everyone else, they copied the source code. They copied the source code, I'm sorry for the word, they shield the copied source code so much that they got a lot of usage. So, no, but in AI, you cannot do it. In AI, you cannot, it's the source code, it's not open source, that you go and copy someone else's source code, the training data, or the model, you cannot do it. It's proprietary. You spend a lot of time to train this model. You get you make a lot of trade-off decisions. Like an example that we had before: do we want 99%, which takes longer, or do we want 98%, which then takes 1%, like a calculation time, real-time AI calculation time. So you do a lot of trade-offs. You do a lot of iterations. It takes a time. Now in DeFi, and most of DeFi, it was copied. There was an initial innovator, like a Compound for the money markets, and they open source the source code. And there was a banker, the banker who did like automated market makers, the AMMs. Then Uniswap copied banker, I think, modified a little bit. Of course, Uniswap knows a little bit better, but they modified. And then everyone copied the Uniswap. Now, but this was the initial innovators, and that's how this DeFi was pumped up, was shielded up. But in the AI, we need models. And models, they need engineers. This needs a real thinking. So, yeah, okay. And what Tarmo mentioned before is like the Web3 should go back ahead the curve. It should become again an innovative. And it should not be again this copy paste that you copy someone else's source code, you change a little bit the UI, you create a new shilling, and you just create a token. No, the innovation means thinking. Innovation means writing source code, analyzing data, running scripts, doing algorithms. That's an innovation. The DeFi innovation is, I'm very happy to discuss this in some other Twitter spaces about this topic. The DeFi innovation went very much on the copying someone else's source code and doing shilling around of this. Of course, there's now a lot of engineers who will protest about this, but I will be happy to discuss with all of them. So, but what I want to say is, and is this, that the innovation will be if you develop algorithms. Innovation is if you analyze data. This is the innovation.
And this is the future of blockchain. Blockchain data has enormous value. Just think about this, what Tsuki paid for WhatsApp. And we have this data, and this data can be mined, and from this data you can calculate things which are unbelievable. And this is the next step in blockchain adoption, and to bring these algorithms over to people, to open these algorithms to the people, especially the newcomers, and then we will see how Web3 will start growing. So convergence of Web3 and AI is actually needed to start adopting blockchain.
Yes, let's get back to the initial title of our Twitter space. It's an AI and a Web3 convergence. So on one side, fraud detection solutions so that we get the newcomers unscammed into the root, into the Web3. And then in a parallel, the solution so that the Web3 platforms, they can start to target the real users and not to use some, how do we call it, like old school approaches, like a pre-Web2 approaches in a Web3 marketing approaches. And this will bring adoption. So, and more conversions. Yes. Okay, now I'm looking on the time. So Tarmo and myself, we said like we don't want to stretch over 60 minutes. Okay, Tarmo, let's both say a little bit over like make some conclusive statements and.
I'm very positive. I'm very positive because what we have shown is what is the future of blockchain. And by bringing in AI elements and opening these algorithms to all community, we can transform blockchain back to the root what was intended. So I'm very positive, Martin. Back to you.
You said a very, very positive statement, back to the roots, back to the innovation, back to the leading curve, not running after the Web 2, but running before the Web 2. And if you're speaking AI and Web3 convergence, that's what should happen, that's what has to happen, that the Web3 will become again a leading power, ahead the curve, and with AI will enable it, and we made in today's Twitter space, okay, we are overstretching it a little bit, so we made in today's Twitter space then pretty many examples. One is the fraud detection, how we create a trust between the anonymous users. That is then the one-to-one targeting for the Web3 platforms. But this is all AI, and with AI, then a Web3 can develop much further. We are at the moment behind the curve. It has to move then in the front of the curve. Ahead the curve, sorry, ahead the curve. Yeah. Okay, Tarmo. So should we complete
today's for today? Next Twitter space we can discuss what are real limitations, why Web3 don't grow, and show real limitations of it and solutions for it.
Why it's a little bit stuck and how to get out of this stucking situation. Yes, we can do it. We can do it again in, let's say, in 2 weeks. That next week we have a Telegram AMA as usual that we are writing. But I start to like more and more the speaking, because if I keep getting the speaking mode, it's like kind of difficult to stop like speaking.
Okay, let's stop it now, Martin. Yeah.
Okay, guys. Then thank you for listening. Thank you, guys. So till 2 weeks again. Bye. Bye.